An excavator arm lifts 40 tons of earth like it's nothing. A bulldozer blade reshapes a hillside in minutes. Behind every massive lift, every precisely controlled dig, there's no giant gear train, no heavy chain drive, just pressurized fluid, sometimes moving through lines no wider than your thumb. This is hydraulics unleashed, and the science making it all possible traces back to a single, deceptively simple rule. Before engineers formulated mathematical laws, ancient Greek and Roman builders used water-driven wheels and screw lifts to hoist massive stone blocks. Harnessing fluid for raw power required a leap from basic observation to formal science. In 1648, French mathematician Blaise Pascal discovered that pressure applied to a confined, incompressible fluid transmits that force equally in all directions. In 1795, Joseph Bramah patented the first hydraulic press, proving that a tiny input force could multiply to crush solid metal. By 1882, Sir W.G. Armstrong built the first hydraulic-assisted excavator prototype, replacing bulky cables with fluid lines. In 1948, Italian brothers Carlo and Mario Bruneri built the first true hydraulic excavator, establishing the 360-degree swing architecture. When Hans Liebherr mass-produced the compact L300 in 1953, construction machinery gained the compact, highly concentrated force amplifier that still drives the industry today. When hydraulic oil is sealed inside a system, applying force to one point sends that exact same pressure throughout the entire fluid. Because liquid cannot be compressed, it acts like a solid steel link, transmitting the push instantly. The secret to multiplying this force lies in the size of the piston. If you pump fluid from a small chamber into a larger one, the pressure stays the same, but it acts on a much bigger surface area. A piston with 10 times the surface area of the input pump will deliver 10 times the force. On a modern excavator, this simple ratio turns engine power into massive strength. Instead of relying on mechanical gears and cables to lift and tear, the machine routes highly pressurized fluid through a network of steel lines. The excavator divides this power into separate movements. The boom lifts the main structure, the arm reaches out, the bucket curls to bite, and a rotary swing motor rotates the entire upper frame. As a hydraulic systems engineer explains, in a 20-ton excavator, the pump sends oil to the boom cylinders at 5,000 pounds per square inch. When that pressure hits the wide face of the internal piston, it multiplies, producing over 100,000 pounds of thrust. While linear cylinders push and pull to move the heavy steel arms, rotary hydraulic motors use that same fluid energy to spin the machine 360 degrees. This setup ensures that motion comes from fluid routed through the machine instead of mechanical gears. True strength comes from this fluid control, transforming a diesel engine's output into surgical, unstoppable force. Wheel loaders are the high-speed workhorses of construction sites, constantly sprinting to scoop, carry, and dump tons of gravel. To maintain these rapid-fire cycles, the machine relies on a highly coordinated network of specialized hardware. It starts at the reservoir, a steel tank holding the oil supply while letting air bubbles escape and debris settle. From there, the pump draws the fluid. While basic loaders use rugged gear pumps for constant flow, high-performance models adopt variable piston pumps to adjust power on the fly. To raise the massive loader arms and tilt the bucket in under a second, the oil rushes into spool-type directional control valves. These valves act like traffic controllers, routing pressurized oil to the exact side of the double-acting cylinders to instantly tip the bucket forward or pull the arms back. Keeping this oil clean is a constant battle. Microscopic dirt particles act like liquid sandpaper, carving grooves in polished steel parts and causing internal oil leakage that robs the machine of power. As a heavy equipment technician points out, fluid contamination is the primary threat to these machines. A single grain of sand can scratch a valve spool, causing internal leakage that turns a lightning-fast loader into a sluggish, unresponsive machine. High-capacity filters catch these tiny invaders, while spring-loaded relief valves stand guard as pressure insurance, opening instantly if pressure surges past safe limits. Because bouncing across uneven terrain creates violent shocks, gas-charged accumulators act as shock absorbers to cushion the circuit. To wrap up the loop, heavy-duty coolers prevent the oil from overheating and thinning, protecting the flexible hoses and tight rubber seals that keep the system pressurized. A crawler bulldozer's brute strength depends entirely on how it directs its massive power. At the front of the machine, double-acting hydraulic cylinders manage the heavy steel blade. Lift cylinders raise and lower the assembly, while tilt cylinders angle the blade to slice through hard earth or grade uneven terrain. But the real magic happens in the drive system. Many modern dozers use a hydrostatic transmission rather than a traditional mechanical gearbox. Here, variable displacement pumps send high-pressure oil directly to individual hydraulic motors on each track. By adjusting the flow to each motor independently, the operator can execute smooth, continuous turns under full load, spinning one track faster than the other without losing pushing force. This constant movement demands extreme efficiency. Older machines relied on simple open-center systems that pumped oil constantly, wasting fuel and generating excessive heat when idle. Modern bulldozers swap this for closed-center, load-sensing circuits. By using variable displacement axial piston pumps, the system only produces flow when the operator actively calls for it. Proportional electro-hydraulic valves act as the precision layer, converting electronic joystick inputs into exact fluid movements. These valves open in minute increments, allowing the blade to shave off inches of dirt with surgical accuracy. An original equipment manufacturer product manager explains, "Load sensing technology completely changed dozer performance. We no longer fight heat buildup because we only build pressure on demand. It turns raw engine horsepower into highly controllable, efficient work." Even the strongest steel systems have vulnerabilities. When suction pressure drops too low, vapor bubbles form in the oil and implode violently, a destructive process called cavitation that eats away metal pump surfaces. Shutting down the diesel engine does not mean the danger disappears. Trapped residual pressure remains locked in the cylinders, waiting for a mechanic to crack open a fitting. At 5,000 pounds per square inch, a pinhole hose leak acts like a needle, capable of injecting toxic oil straight through heavy leather work gloves and into human tissue. This makes safety an exact discipline. Technicians rely on strict lockout-tagout procedures to physically isolate and bleed off every ounce of pressure before turning a wrench. A simple daily walk-around, checking for swollen hoses, wet spots, and minor abrasions, keeps these mechanical giants running safely. It is a daily routine that ensures respect for the fluid. Digital intelligence is merging directly with high-pressure fluid. Inside modern excavators and wheel loaders, sensors monitor pressure, temperature, and oil flow, sending real-time data to an electronic control unit over a high-speed CAN bus network. This constant stream of information lets technicians predict component wear and schedule maintenance before a breakdown occurs. Efficiency is also rising through energy recovery. When a heavy loader decelerates or an excavator boom lowers, regenerative valves capture that kinetic energy and store it in accumulators. Running on biodegradable, vegetable-based fluids, these smarter hydraulic networks turn sustainability into a raw performance advantage. As we build the smarter, greener cities of tomorrow, the raw strength of hydraulics is merging with digital brains. These massive machines are becoming cleaner and quieter, but their muscle remains unmatched. The future is being reshaped right now. What heavy machine excites you most? Let us know below.